The decarbonisation of industry is a critical part of the energy transition. In this episode of the EU Energy Projects podcast, I am joined by Gianluca Lipari and Daniel Pombo from the AGISTIN project, which aims to help industrial grid users to rapidly decarbonize. Now, for listeners who may not be familiar, what is AGISTIN and what problem is it trying to solve in Europe's energy transition?
I will take this question. And first of all, thanks for having us in this podcast. As you said, AGISTIN is a European project. It's an innovation action and aims at providing solutions for integrating storage into industrial processes. So the project looks at what type of storage technologies are there. So different ones for different type of applications, and wants to provide solutions in terms of integration and utilization of storage in conjunction with the industrial processes. So the storage allows to use local generation, like PV generation, to provide energy to applications like green hydrogen production, as well as irrigation facilities in Spain. And that's our project. That's what we are trying to do. And there is not only the storage, but also a lot about the components that allow to integrate the storage, the control algorithms. So there is a lot of research and innovation behind this.
Daniel, it also focuses on advanced grid interfaces and DC coupling for industrial sites, right? Why is this approach so important, especially right now?
The importance of this approach is related to the fact that when you are moving into a hybrid ecosystem in an industrial site, for instance, you're going to have different toys to play with. You're going to have the industrial process, you're going to have the generation, the storage, maybe multiple types of storage. And then you need a way for them to speak on the same language in the same way. So that's where the interface comes in. The interface is basically what allows you to plug in and out in a easy way all of these components, and that they coordinate and they play together nicely.
Gianluca, you already mentioned in your previous answer the various assets, right? Can you please explain now how AGISTIN integrates multiple assets like batteries, solar PV, etc., into one system?
Yes. So, as I said, the idea is to use all the resources that are available in an industrial site. So, there is quite often, and even more and more nowadays, local generation from renewables like PV. That's one of the type of assets that we integrate. Then, specifically to our project, we have storage solutions, different ones with different characteristics. For example, to cope with longer or shorter term type of variations. And then there are the industrial loads. We can imagine an electrolyzer in one of our demos, or electric vehicle charging infrastructure, or pumping stations in the agriculture. All of these are on site and are used to optimize the usage of those resources and provide all the needed energy for the industrial process. For doing that, and Daniel mentioned that, there is the need to interconnect them physically, so with the DC bus in this case, or mostly in DC, and then also to control them in the best way possible to optimize the usage of resources and also the interface towards the grid.
Daniel, what role do control algorithms play in improving efficiency?
Yes, so in this project, we are trying to move away from all of these energy management systems that operate basically on an if then else basis. And we're trying to move into deterministic optimization and maybe a stochastic optimization. So we are actually going to have an actual equation there and some constraints and whatnot, so that the system is looping and trying to find the best set points for the current and near future operating conditions that we foresee.
And you're focusing on open source models. How do they contribute in achieving these goals also?
Maybe I can start. Yes, we have a stream of work on modeling, because that's the first part of probably every project, modeling what is the scenarios that we have. So we started by defining models that we also published as open models in our website of all the components that we foresee. So the type of assets as well as the converters. And we believe that using open models is also a good way to provide an output from the project to the research community, the innovation community, that can take those over and maybe apply also to their studies or their projects. and also, of course, gives a way to validate what we are doing, because being open also exposes what we are doing, and people can, yes, use it, but also maybe improve what we've done so far.
And constructively criticize it
Of course.
sometimes, right?
If I,
Your thoughts,
if I
yes?
may add something, it all boils down to the scientific process. There is a need for science to be replicated and to be redone by other people in order to validate and build trust on it. It's almost a duty when you are being paid by the taxpayer through the European Union to release all that back to society so that it can be picked up again and again, improved in an iterative process.
Staying a little bit on the technical side of the project, what are the advantages of DC models?
And DC has the potential advantage of saving us conversion stages. So basically, when you interconnect, let's take a simple example, a battery with a PV system. Both of them, the PV will generate in DC and the battery will operate in DC. But then our grids are run on AC normally for multiple reasons. If you have 3 or 4 components that are operating in the end at the asset level on DC, but then they have to interface with the grid in AC, at some point you will have to invert that signal. The question is, how, at which stage do you do this? How many times do you do this? Is there a way to save conversion stages? At every conversion stages, you will lose a certain percentage of energy just in conversion losses. So it's about making the system more efficient. The problem is, are there available products that you can go to the shop and buy so that you can do this? And the answer is very complicated, but generally no. And then there are a lot of questions also regarding protection schemes and so on. So this is something that the research is paving the path forward, but at some point industry has to pick up and start producing solutions that we can use in order to implement these systems.
Let's discuss audience a little bit, because if there are some issues also, the audience need to be, or the focus audience of AGISTIN needs to be aware. What would be the tangible, let's say, benefits that industrial grid users, which are part of AGISTIN's audience, will benefit from?
As Daniel said, the idea is reducing the complexity of the integrations of, in this case, renewables and storage and industrial processes. That is our ultimate goal. As Daniel said, also it's not off-the-shelf type of solutions. So that's why we are working on the modeling, the simulation, then the testing first in a small scale, and then we want to go into the full deployment in the demos. That's one of the advantages we see internally, let's say, in the customer area. We also see the option of having a single point of connection to the grid. So where was Daniel was saying on then going from DC to AC, if there is that single point that can be controlled or is easily controlled by the industrial user, then it's easier for them either to provide services to the grid or maybe be able to cope with the limitation that the grid has or the DSO imposes. So, for example, no injection at certain time of the day, or reducing the consumption when needed. So those should help also integrate with the grid, especially when there are congestion limitations. Nowadays, we see a lot in many cases for different type of users that the utilities cannot accommodate all the requests. So if any help can come in that direction, that's always useful for all the stakeholders.
Yeah, so the key in the end is flexibility. And flexibility is a very fuzzy term. It can mean 1,000 million things, and it depends on the person that is speaking about it. So Gianluca has hinted at multiple things. There is flexibility in having a plug-and-play philosophy with it as assets. There is flexibility in being able to coordinate with the grid in order to strengthen it, to provide auxiliary services and all of that. But there is flexibility also on being able to provide connection agreements for massive loads like these data centers that are about to come in our systems. So if we have the capability of controlling in a way the amount of available power that they can drag during a period of time, we may be able to grant connection access much faster prior to having eventual transmission upgrades or distribution upgrades.
There's also, however, the issue of grid capacity or lack thereof.
Exactly.
So how does the project help avoid delays in electrification and decarbonization?
It's going in the direction that I was hinting about it right now. So AGISTIN is not really covering directly grid expansions of any kind or really dealing with reinforcements. The idea is that the advanced grid interfaces that cover in the project are expected to help in future projects to move into that realm, basically.
Okay, so we discussed the technologies. I want to go a little bit back and ask you, where do you test them? And what real world scenarios can you tell us about?
Yes, as I said, we have two steps of verification. The first one is on a small scale, so lab scale testing. We have three of them in Germany and in Spain. One deals with electric vehicle charging infrastructure. So, together with Fraunhofer, we are testing our solutions in their campus in Kassel. Then we have one on small scale hydrogen production, again with Fraunhofer, and a third one on a small scale pumping station and hydro station in Spain. Those are meant for validating the concept that we have before scaling them up into the full scale size demos. We have two of those. One is the green hydrogen production in the Netherlands together with the Shell, so electrolyzer in Netherlands. And the second one is an irrigation community here in Spain, where we want to connect the storage, not only the electrical storage, but also the reservoirs of the irrigation community as long-term storage.
I think we should explain what the irrigation demo is, because it's a bit of a weird one.
Absolutely.
Let's say. So everyone has been talking about this green hydrogen, right? So there is no need to explain anything about it. But the irrigation case is pretty interesting. So the idea is that you have agricultural fields that need to be watered for obvious reasons periodically during the year. In order to get that water, you have a water distribution system that moves through the mountains. So it picks up water at the bottom from different aquifers or from desalination or from whichever water source, and it starts pumping it up the mountain to the different reservoirs in order to satisfy this demand. The idea is that these systems, basically 70% of their operational costs are electricity bills. So if you couple these basically pumps with PV plus some sort of small storage to handle small variations, clouds and whatnot, you end up reducing the electricity bill by a lot. Furthermore, we have cases in which these pumps, of course, you reach the tip of the mountain and then there is gravity taking the water down again to the next reservoir. So these waters right now, it's being passively slowed down by the time they reach the next reservoir. If we put there some turbining capability, it's not that you're going to generate, but you're going to reduce the water consumption the electricity consumption of your system. So that's the overall scenario test case demo. And someone might think, but is this actually scalable? This is something that you can apply somewhere else. We have terawatts of potential power across Europe only. All over the Mediterranean area, there are multiple of these systems in every single country.
Okay, so it is scalable, it is applicable, because I wanted to ask you, we are a bouquet of countries in the European Union. So every country has its own mentality and its own level of progress.
Exactly.
So this should not be a problem, let's say, with AGISTIN.
No, definitely not. We are talking about green hydrogen, which is the buzzword, and it's moving all over Europe. And an electrolyzer can be plug and play wherever you have some sort of water. And then these irrigation systems, whenever you have agricultural fields, you're going to have some of this.
So what opportunities then exist for collaboration with other projects, other industry players, or policymakers even?
Starting from projects, we are indeed in a cluster of projects which were funded on the same call. We have been working together on aligning what we are doing or understanding what are the complementary approaches that we are using. So that's one of the activities we are already doing since the start of our project, since the start of the cluster. With industry, of course, it's very important. That's why we have the demos. We have the green hydrogen production customers inside the consortium to test in real world our solutions, and then that it's also up to them to scale it up in their whole system. Policymakers, that's one also of the stream of work that we're doing, analyzing what are, for example, the grid codes requirement, what is the regulation that allows the deployment of these type of solutions, if there are gaps, and there are some, and what could be from the project or even from the cluster of projects, what could be the recommendations in terms of changing or adapting some codes, some regulations to allow a faster integration of these type of solutions.
Yeah. One simple example that we can put is with the Spanish demonstrator, we have these irrigation systems, right? So due to legacy regulations, these water networks were not really able to play in the electricity market or in the energy market because these original regulations were meant to avoid conflict of interest for the companies operating these distribution systems. So that made sense at the time, but right now is constricting us on the things that we can implement. So we've gotten some special permissions to operate kind of like a sandbox, but things need to be adapted so that we can fully exploit what technology allows us to do nowadays.
And how do you see this innovation shaping Europe's industrial energy landscape in the next, let's say, decade?
To take it?
Right, it's a tough one. So not a single one of these European projects is going to revolutionize drastically anything, right? You're not going to suddenly change the whole paradigm. But what we are doing is that we are taking the steps towards the broad future that we want to achieve. We want to achieve decarbonizing our industry. We want to decarbonize our electricity consumption. And there is no silver bullet for this. There is no single technology that is going to allow us to do this. And what we see is that one of the key factors is coordination. And that's what AGISTIN is all about. The advanced grid interfaces that allows us to have a decent coordination, avoiding these tailor-made solutions that are so often the case within the hybrid ecosystem.
So what would you call success, let's say, for AGISTIN?
Of course, successful demonstration in our demo site, so being able to show what are the advantages. We also would like to see that beyond the project, those solutions are adopted. One way is also the open model, so see that what we've been doing goes beyond the utilization in the project. And maybe also connecting to your previous question, I would look at it the other way around. The landscape is already changing. When we started our proposal, we looked at some use cases, but Daniel mentioned one. So, for example, data centers. They were not in what we were thinking about, but the constraints in the grid that you mentioned before, also the fact that they could work in a good part in DC. Maybe there are other applications. So porting the solution that we're doing in other applications, in other industrial processes, in other type of world applications, it's very successful for a project, going beyond what we have been demonstrating and having an adoption broader than what we thought when we proposed the project initially.
So on this positive note, I would like to thank you both for this very interesting conversation. Thank you for your insights. And for more insights, join the Enlit community.